So now that we've looked at how do we write names and formulas for ionic compounds that have a fixed charge, so those group 1, group 2 metals, let's take a look at what happens when we work in the transition metal range. So transition metals can have more than one charge. They can be +2, +1, +3, it doesn't matter. Now, ionic compounds, they still have to be neutral though. So once we find out what else it's being mixed with, we have to know what the charges are to get them to balance and be this nice neutral compound. So neutral meaning an equal amount of positives to an equal amount of negatives. So these are the things that can have variable charges. So these are all the elements that are in the middle, right? I included these ones down here, but really we're going to be working with this range in here. So things like manganese, chromium, nickel, copper, cobalt, any of those are great examples of metals that have different charges. Iron can have iron 1, iron 2, iron 3, iron 4. So all of those different things can happen to iron. And depending on what it's mixed with and how much tells us what the charge is going to be. So let's take a quick look at finding charges again. So what is the charge of iron 2, right? There's 2 irons with 3 oxygens. So as this iron comes down, so we're going to break this apart like we did before. And now I'm solving for this area right here. I need to figure out what charge makes this balanced, what makes it complete. So I take that 3, I put it here. I used my periodic table to say, okay, I looked at oxygen. Oxygen is in that -2 column, right? So what's the charge? It's -2. So I have 3 of them. So I have 6 total. I have a charge of 6 above all of this stuff. Okay, so now this over here has to equal 6. So what times 2 equals 6? 3, right? So this has that +3 charge on this side. So remember, the metals are the ones that get the positive charge. They give up electrons, right? So if I were looking at just one atom of this, it is an Fe +3 ion. So that's just one of those metals. So how do we name this thing? Well, transition metals, like we said, are different. The cation, the positive part, can be different. So when the charge isn't the same all the time, we have to tell people what the charge is. I can't just let it go and just say it's iron oxide. It won't work because it could be iron multiple charges with oxygen, right? So let's start out in a similar way though. So just like we did with the fixed charges, I'm just going to write the names. The first one just goes in as is, so the metal goes in as iron. The second part is oxygen, so that anion, the non-metal, is just going to get that IDE ending to it, so oxide. The thing that's changed is we learned that there is a +3 charge here. So I have to tell people that it's a +3 charge. So I'm going to put Roman numerals here to say what the charge is. So if I were to say this name, it's iron 3 oxide. So that's the big difference. We're using Roman numerals. Now, quick refresher. I know some people need it. So we have 1, that's going to be 1 mark. 2, that's going to be 2 marks. 3, that's 3, right? 4, that's where we do the 1V, right? That's the one that changes. Now, I'm not going to do anything more drastic than that. So you just need to know to 4. So let's go through a few examples and see what we can find out. So if I'm looking at my periodic table, right, I'm going to have that out so that I can refer to it because I'm going to look for charges that I can use. So I'm going to break this apart. There's copper. There's only one of those. There's chloride. There's only one of those. Now copper, so I just need to find out what that one thing is, what that charge is. And chloride, I know we got 2 of them. I'm going to use my periodic table to figure out what the charge is. So I go here, it's fluorine, chlorine right there. It's on that -1 category. -1. So now I'm going to start writing in a similar way after I figure out what this is. So it has to equal 2 overall. So it's nothing right now. So it has to be positive 2. So we start in the same way. We know it's copper. C-O-P-P-E-R, right? Copper. Then I'm going to write the next part, chloride. Chloride is escaping me for a second. And then I have to just indicate what the charge is on that copper. So it's a 2. Remember, that charge, these are telling me what the charge is of that metal. Okay, it's not talking about this over here. It's talking about the thing in front of it. Okay, so let's do that same thing over here for iron. So we got over here. Now this one's got a little bit more numbers to it. So we have iron, we have Fe3, and over here we have N, and we have 2. So I look where they are, right? Iron's in that transition metal piece, and then over here nitrogen's in that -3 category, okay? So I'm going to just put down that -3 in here first, so I don't forget. Iron, I have 3 of those, and I have no idea what this charge is over here. I know it has to equal 6, right? 2 times 3 equals 6. That means I have 6 negative things over here, which means I need 6 positive things over here. So we're going to look at the 3. What times 3 gives me 6? That's 2. So this would be positive 2. Great, now I know what I'm working with. So we knew that this was iron, right? So I'm going to write iron. I'm going to write nitride, the IDE ending. Right? And then I got to indicate that charge with those Roman numerals. It's a +2. So I use those 2 lines. Okay. And now let's look last one. Okay. So we have CR. There's only one of them, so I'm just going to put that down there. The one out front, just so I know I got to times just 1. I got my 3 of these BRs, right? So it's BR3. So I got 3 BRs. So I got to look up what BR is. It's going to be in this side over here, BR, right? So BR is in that -1 category. Now let's take a peek. So 3 times -1, so we're going to say it's -3. So 1 times whatever this ends up being, so it needs to equal to 3. So -3 needs to equal +3 on this side. There's only one of them, so balance it out right away. Now Cr, so looking at my periodic table again, is chromium. So I'm going to write chromium. And then bromide, right? Bromine becomes bromide, changing that to an IDE ending. And I got to indicate what that charge is. There's only 3, so we got 3. All right, so what if we have to go from the other direction, right? So now it's the same basic idea, but now we got to figure out what those subscripts are. So let's see, we got copper and oxygen. So I'm going to look over here. I know, looking at this, so I got copper with a 1 charge. So I'm going to look at this. I'm going to put a +1 here. I do not know what this is. And then the other part is oxygen, right? Oxygen, we look at our list. Oxygen right here is in our -2s. So I'm going to put my parentheses. I got my -2. Okay, how do I balance them out? So what do I need to do to either side to make this work? Okay, so if this has a +1 charge and this has a -2 charge, I need 2 of these to equal 1 of those, right? I'm just trying to balance the scale. And now I'm just going to use those numbers that I just put in as my subscripts. So I'm going to look up copper. Copper ends up being Cu. So I put Cu. That number 2 goes down at that subscript. And then I only have one of these oxygens. Oxygen's that nice big O, so it's Cu2O. All right, let's do the same thing for mercury. So let's look up the values for this first. So we got Hg, right? That's mercury on the periodic table right there, Hg. And then we got iodine, right? So we got a nice I there. Now I'm going to look up if I can figure out those charges. The +2 right there, so that's 2. That goes to my mercury, so that's +2. I don't know how many I have. Now the iodide here, I'm going to look that up. Tells me that it's a -1. It's in that first category. So now I'm going to try to figure out how many of each I need to balance it out. I have a +2 here. I have a -2 here, so I need 2 more negative things. So this should be a 2. This can stay that 1. So I have Hg. Because I have one of them, I don't have to write anything. Next, I have 2 of those I's. I2. And then the very last one that we'll do together is lead 4 oxide. So let's take a quick peek here. So first thing we're going to do, we're going to look up what the symbols are for these things. So we have lead. So I'm going to look through. I'm going to look through. Oh, there it is right there. Pb. So lead. Okay. And then oxide. So we have oxygen. Oxygen is an O. Now we got to look at what the charges are. So the charges for this lead, that's a 4. So I know I have a +4 charge on this one. We don't know how many. And then on the other side, we look up oxygen, which we use as an example a lot. So we'll start to find it nice and easy in this -2 column. -2. We got to figure out. I have 2 and 4. So how do I figure this out? What do I do? Well, over here, I definitely have 1 of these and 2 of these, because in order for this to equal 4, I need to have 2 of them, right? And it'll equal 4. All right, so let's start bringing it down into our formula. So we got Pb. There's only 1, so I don't have to write it again, right? And then lastly, I have oxygen, which there's a 2 there, so I got to bring the 2 down. And that's how we write formulas from the name, and we also find out what the formulas are from the name and vice versa. So back and forth, right? So we just have to indicate what the charge is. So with ionic formulas, with transition metals, we have to tell what the charge is. And we do that by using Roman numerals, and it just makes it so that I know what I'm talking about. Now we do have to use a little bit of that detective work to figure out what the charge is, but because we have these columns with these charges, we can work it out. So let's keep practicing and keep going.